Hey everyone, it's Justin again. In this video, we'll be talking about simplifying algebraic expressions, which is going to rely on your new skills with combining like terms and distributing. First, we'll talk about what simplifying means when it comes to algebraic expressions, and then we'll complete 3 example problems together. Chances are that you have heard the word simplify before. In fact, I've even said it in this course. But what do you think simplifying means in algebra? Simplifying just means making something simpler. If we have a big expression like this, what do you think we can do to make it simpler? Yeah, we can actually do these operations. If I do all of these operations, following gems of course, then I can combine these terms down to a single number. When you've simplified an expression as much as possible, this is called simplest form. But what about an expression like this, with variables in it? What do you think we could do to simplify an expression like this? Well, since there are variables in here that I don't know the value of, I won't be able to simplify this all the way down to one single number. But there are still a lot of operations that I can do. We'll want to use our knowledge from the previous lessons to simplify this as much as we can. Now, we'll come back to this expression by the end of the video, but let's do a couple of other example problems first to build ourselves up to it. Our first example problem here asks us to simplify this expression. If we think about gems, what is the first thing that we should be doing to simplify here? Well, gems says to start with groupings, and we do have a grouping here with 3 plus c squared. But can I do anything with this grouping? No, since we don't know what the value of c is, we can't substitute for it. And 3 and c squared are not like terms, so we can't combine them either. Since we can't do anything with the grouping, we have to move on to exponents. I certainly have exponents in this expression, but can I do anything with them? No, I can't. Both of my exponents have variables for their bases, and since I don't know what value c represents, I can't do anything with those exponents. Okay, next I'm looking for multiplication and division. Do I have any of these that I can simplify or calculate in this expression? Aha! This 5 is being multiplied by the grouping, 3 plus c squared. When you have distribution inside of an expression, it's important to check the operation before it to see what sign you're distributing. Since this is plus 5, I'm going to be distributing a positive 5 to both terms. Go ahead and distribute the positive 5 now. Positive 5 times 3 makes positive 15, and positive 5 times c squared makes plus 5c squared. Let's bring everything else down. Do you see any more multiplication or division in here that we can do? Nope, that's all of it. We have lots of multiplication between coefficients and variables, but without knowing what number the variable represents, we cannot multiply those together. All that's left is addition and subtraction. Do you see anything that we can do in this expression with addition or subtraction? Remember, when we're adding or subtracting terms, we can only combine them if they are like terms. What like terms do you see in this expression? Plus 5c squared and minus 9c squared have the same variable with the same exponent, so they are like terms. And they're actually the only like terms here. So what do I get when I combine them? Positive 5 minus 9 makes negative 4, so I end up with negative 4c squared. Everything else comes down since they can't be combined. We've gone all the way through our order of operations and done everything that we can. So this is in simplest form. Remember that these terms can be in a different order and still be equivalent. For example, we could put them with the exponents descending like this, which would also be a great final answer. Our second example also says to simplify, but with this new expression. This one's a big fraction. So how do you think the order of operations applies to an expression like this? Well, remember, each side of a fraction actually functions as a grouping. 5 is by itself in the denominator, but our numerator has a lot going on. Since it's a grouping, we'll need to simplify this numerator as much as we can before we even think about dividing by 5. With this in mind, pause the video here and try to simplify this one on your own. As I mentioned, GEMS tells us to start with groupings, and our biggest grouping to tackle is this entire numerator. When we need to simplify a large grouping, we just use GEMS again inside the grouping. I have another grouping with 6n minus 8, but they're not like terms, so there's nothing I can do with it. I also can't do anything with this exponent, so I'm on to multiplication and division within the numerator, which means it's time to distribute. Notice that this is minus 3. That means I'm really distributing a negative 3 here. So to help me remember that, I'm going to circle the whole minus 3 and then use my arrows to show my distribution. Negative 3 times 6n makes negative 18n, or minus 18n. Then, since I have minus 8, I can think of this as negative 3 times negative 8, which will make a positive 24, or plus 24. Remember to always be careful with your signs. Circling operations and signs together, just like how I was doing, can be very helpful. Now that my distribution is done, I want to bring everything else down. Is there any other multiplication or division that I can do within my numerator? Nope, not without knowing what number the variable represents, so we are on to subtraction and addition, which means it's time to look for like terms. What like terms do you see? 8n is like terms with minus 18n, because they both have an n with no exponent. Plus 11 is like terms with plus 24, because they're both constants. Does minus 7n squared have any like terms? No, it's the only term with an n squared, so it will just stay by itself. 8n minus 18n makes minus or negative 10n. And positive 11 plus 24 makes plus or positive 35. Breaking down that minus 7n squared, is there anything left that I can simplify in my numerator? Nope, we have done everything we can. If we look at our whole expression, we've now handled all of the groupings, and there weren't any exponents that we could do anything with. Is there any more multiplication or division I can do? Yeah, the whole numerator is being divided by 5, so I have to distribute that division. If you haven't already, pause the video and distribute that division now. Negative 10n divided by 5 makes negative 2n. Plus 35 divided by 5 makes plus 7. And then minus 7n squared divided by 5, that is not going to divide evenly. But that's okay. Fractional coefficients are perfectly fine, so this will just be minus 7 over 5n squared. This answer is fully simplified and correct, but of course there are always multiple ways to arrange the terms. If we want to arrange it with the exponents descending, for example, it would look like this, which would also be a perfect final answer. Our third and final problem also asks us to simplify. This one might look familiar because we actually looked at it back at the beginning of the video. Now that you've had some practice, pause the video and try to do this one independently. Working through GEMS, there are 2 groupings in this problem, but be very careful. Remember that like terms have to have the same variables with all of the same exponents. In our first grouping, we have one term with ab and one term with a squared b. So these are not like terms. In the second grouping, we have one term with ab squared and one with a squared b. So those aren't like terms either. That means there's nothing to do in my groupings. Next up is exponents. I do have some exponents, but there's nothing I can do with them, so it's on to multiplication and division. I have two instances of multiplication that I can simplify. This 2 is being multiplied by this grouping, and this -3 is being multiplied by this grouping. Since there are 2, I should do them from left to right. Distributing that 2 times 3ab becomes 6ab, and 2 times minus 4a squared b becomes minus 8a squared b. We could bring down the plus 7ab since it's not involved in any multiplication. And then in our second distribution, notice that the operation before the 3 is subtraction. So I'm distributing a -3. -3 times ab squared. Well, since this term doesn't have a coefficient, its coefficient is really 1. So -3 times 1ab squared makes minus 3ab squared. And lastly, we have -3 times -6a squared b. A negative times a negative becomes a positive. So this becomes plus 18a squared b. With our multiplication done, we're just down to addition and subtraction by combining like terms. Knowing that like terms have to have the same variables and the same exponents, what like terms do you see here? 6ab and plus 7ab are like terms. Combining them makes 13ab. Minus 8a squared b is like terms with plus 18a squared b. And combining them makes plus 10a squared b. And minus 3ab squared doesn't have any like terms because no other term has an a without an exponent and a b that is squared. So it'll just come down by itself. Now this may seem tougher to rearrange in a nicest order since it contains more than one variable, but let's try our best. I'm going to start alphabetically with a and put the term with the highest a exponent first, which is 10a squared b. I have two more terms with an a without an exponent, so to figure out what order to put them in, I'll look at the b and put the higher b exponent first. So next will come minus 3ab squared. And last, we'll have plus 13ab. There are no operations left here that we can do, and our terms are ordered nicely, so this is our final, fully simplified expression. Simplifying algebraic expressions with variables is not much different than evaluating algebraic expressions with only constants. We still want to follow our order of operations to help make the expression as simple as possible. But since we can only add and subtract like terms, your final answer will likely have more than one term in it. To put that final answer in the best form, order the terms alphabetically using their variables, and then order them with the exponents going from largest to smallest. Make sure that your guided notes are complete and that you've written out clear, organized work for each example problem so that you can reference them later. There is some additional practice in your PDF that you should complete before finally moving on to the practice game. Good luck, and I'll see you next time! Hey.